This is for Algebra 2 with Trig. It's working on a factoring worksheet. We're factoring out a GCF. So you can always check it by distributing that through to get what you started with. Another GCF. We see that 3 goes into 3 and into 9. And the smallest exponent that they all share is an x squared. So we're missing an extra x to make x cubed. What number goes into all of those? The smallest exponent for the x's, the smallest exponent for the y's. It's got the 2, it's got the x squared, it needs a y cubed. It needs a 4, extra x and a y. It needs a 2 more x's, and it has the y. Notice that none of these pairs or monomials have the same thing. These two have y's, but that one doesn't. These two have x's, but that one doesn't. This looks like what multiplies to be 10 and adds to be 7, 5 and 2. This is a GCF. What multiplies to be positive 2 and adds to be negative 3. Looks like a 3 goes into all of those. The lowest exponent for the x's is 1. Looks like they all have a y squared in them. Looks like that could still be factored. What multiplies to be negative 10 and adds to be positive 3? I think 5 and 2. A positive 5 and a negative 2 multiply to be negative 10, but add to be positive 3. Okay, this has a leading coefficient other than 1. So we multiply to get 12. That adds to be 13. So we know that's going to be negative 12 and negative 1. Then we factor by grouping. You always have to have a placeholder out in front. What's inside the parentheses has to be exactly the same. Both these monomials are multiplying x minus 4. So you don't have to write x minus 4 twice. It's 3 times x and 3 times 4, and negative 1 times x, and negative 1 times negative 4. Alright, this looks like a tricky one. So we're looking at 15 times 12, 180. That adds to be 8. We know that it's going to be a negative 180, so the larger number's got to be positive to add to be a positive 8. Negative 1 and 180. Negative 2 and 90. Negative 3 and 40. Negative 4 and 30. Negative 5 Oh wait, -4, and 4 doesn't go into it. There we go. Because I know 5 and 36. 6 goes into it 30 times. 7, 8, 9. -9 goes into there 20 times. 10. How about that one? 10 and 18. So we're going to say 12x squared minus 10x plus 18x minus 15. Factor out what you can. Bring down your sign. Factor out. 3 times 6. 3 times -5. What's inside the parentheses has to be exactly the same. That was a tough one. What multiplies to be 12 and adds to be 17? We've got no, I don't think I see it. We'll run through them anyway. 1 and 12, 2 and 6, 3 and 4. Then it would be 4 and 3. So none of those are adding to be 17. So that looks prime. Not factorable. Here it looks like we have the difference of perfect squares. So we're going to treat that as x squared minus 4 squared. 4 squared is 16, so that's going to be x plus 4, x minus 4. This is also the difference of perfect squares. We have two things being squared. Ooh, this is the sum of perfect squares, not the difference of perfect squares. So it's prime. Because it is the sum of perfect squares. Here, looks like we pull a 2 out and an x out. Now it looks like that's the difference of perfect squares again. If you square 3x, you get 9x squared. If you square 5, you get 25. So it would be 3x minus 5, 3x plus 5. This is the sum of perfect cubes. So we have x cubed plus 3 cubed. You can factor the sum of perfect cubes, the sum of perfect cubes apart, but you cannot factor the sum of perfect squares. So we take our a term and our b term, Then we square the a term. You multiply those two and change the sign. Then you square your b term. This trinomial will never be factorable in the sum or even the difference of perfect squares. Factor out our 2. Then we're going to look and see, this is the difference of perfect squares. So you take the cubed root of your first term, the cubed root of your next term. So now you have your a and your b. Square your a. Multiply the two together. You always change the sign each time with that. Looks like an x squared can come out. Looks like a y can come out. Okay, so because this can be written as 2x cubed, this can be written as 3y cubed, this is also the sum of perfect cubes. So we got 2x and we have 3y. We square our first term, change the sign, multiply the two together, and you square your last term. Factor by grouping. Don't need to put a 1 for an exponent. Okay, because it's the sum of some squares, we can't factor that apart. Again, can't factor that apart because it's the sum of two squares. Three goes into this 4 times. 2 goes into that. Oh, this looks like that would be a -3. Not factorable. Because your parentheses are not exactly the same. If that was a different sign, it would have worked out great. This is still up. This is the sum of 2 cubes. Or 2 squares, sorry. So not factorable. This is in the pattern of a quadratic. What multiplies to be 80? 20 times 4 and adds to be 24. Again, can't be factored apart after that. So to factor this apart, 2b squared plus 3 and b plus 6.